Hello and welcome. You are watching the talk, Making AI Securely Available to the Masses with HAProxy. My name is Nathan Mellis, and I'm the head of engineering at Modsy. For more information about me, you can find me in all the usual places, Twitter, LinkedIn, GitHub, etc. As the talk's title suggests, we at Modsy wanted to make an instance of our product freely available to allow developers and data scientists to experience our product and the power that API-driven AI can bring. Modsy is a new ModelOps product that helps bridge the AI valley of death by solving the last mile problem of getting AI and ML models into production. For more info about Modsy, you can find us at the links below. Today, I'll be sharing some of our journey with HAProxy as we set about to deliver this free instance in a secure manner. We'll cover some basics, like why secure proxies are needed and what some of the basic configuration settings are, along with examples of lines you can put in your HAProxy config file. Finally, I'll share the mechanism that we landed on to automatically deploy and configure a highly available HAProxy cluster in AWS, along with a few other AWS tips and tricks we picked up along the way. So let's get started. So let's play a game. I like to call this the game of good idea, bad idea. So things we can put in the good idea bucket. Building a cool application that allows the use of cutting-edge artificial intelligence through a simple API call. That sounds like a good idea. Put it on the internet for anyone to sign up for and use. That's great. Drive adoption, get users. It's what product companies are all about, right? Make the application incredibly scalable to support a great experience for many users. Also sounds like a good idea. Now let's talk about some things that go in the bad idea bucket. Bad idea. Assuming that no one is going to attack your application. The internet is a scary place after all. Bad idea. Assume that your users won't purposefully or accidentally DDoS your application. Even the most well-meaning users at times can cause problems if they're not careful. And finally, a bad idea is not putting any limits in place, which can cause your operations lead to come and murder you in your sleep when they get the AWS bill. Yeah, we'll just leave that one right there. So what's the problem? Well, the problem is that the internet is full of jerks. Putting your web application publicly out on the internet can be a really terrifying prospect. And especially when you allow anyone to sign up with an email address because they're effectively anonymous at that point, since email addresses are so easy to create and use. Besides that, attacks are becoming more and more prevalent and more sophisticated and can be orchestrated at a mind-boggling scale. Everything from state actors to botnet runners to just bored people who want to ruin your day. And at the end of the day, you want to provide a great experience for your users without letting these jerks, make you or your users have a bad day. So basically, you want a buffer between the big scary internet and your nice application that can protect you from common kinds of attacks and disruptions. So let's talk about HAProxy. This is HAProxy Conf after all, and I'm sure that's why you're all here. So we selected HAProxy for a number of different reasons, and some of which we'll go through today. For more, I'm assuming most of you know what HAProxy is, otherwise you probably wouldn't be here. So let's talk about some of the basic configuration settings you want to set up when you go to deploy HAProxy in production. And the first one is what hopefully is the most obvious. Use TLS. Secure all of your traffic so that the traffic being sent from your users can't be intercepted and read by a third party that should not be reading that traffic. So how do you do this? Well, it's pretty straightforward. First, you have to turn it on. Use TLS 1.2 or higher. Set a few additional parameters. And then depending on whether you support HTTP2, gRPC, some of those things, add some headers, turn on strict transport security, and then redirect all HTTP traffic to HTTPS. This is all pretty straightforward boilerplate stuff, but nonetheless is very, very, very important with services out there like Let's Encrypt these days. There's really no excuse not to run everything with TLS all the time. The next setting is also related to TLS, and this is to ensure that proper routing happens. Now, chances are if you're running HAProxy, you're probably hosting more than one domain behind it, which means that you're going to be routing traffic depending on which domain it is. Now, the typical setup that you would think would be to check the host header for what the domain is and then route based on that host header. But if you're using TLS, checking the host header is not enough because an attacker can set the host header to something other than the domain that the TLS certificate is for, thus allowing them to potentially bypass any restrictions you have in place and go to some other site. You want to make sure that your traffic is always going to the site that it was intended. Thankfully, this is pretty straightforward. Use SSL FC SNI or server name indication instead of checking the host header. This will ensure that the rule to select the backend will only work on the domain that was publicly verified from the TLS certificate. This is pretty straightforward, but a very good thing to set. Next, let's talk about mod security. So I don't know if you are aware of the OWASP rules, but mod security is a package that's available for HAProxy as well as other reverse proxies out there that sort of automatically handles and has rules for a lot of the common OWASP conditions, things like remote code executions, things like unprotected known config files that might be available if a server's misconfigured and stuff like that. So here we have an example URL where someone may have accidentally forgotten to turn off some CGI bin scripts from a default configuration that would allow someone to execute an arbitrary command through a URL. And so just using mod security, even with the default rule sets, will disable a lot of these kinds of things. And of course, you can customize and tailor the rule sets to your own liking. And there are commercial vendors out there that will sell rule sets as well that are more specific and targeted and more strict. So this is an example of how you would turn it on. You load the module, which means it has to be present on the HAProxy server. We'll talk about that later. And then in your backend, you tell it to filter based on a rules file, and then you point it to where the rules file is. Pretty straightforward. Next, let's talk about GeoIP filtering. So let's say that either the country that you live in, or your company's policy, or the fact that your application has information that's export controlled, or any of the above reasons, you need to filter out traffic coming from certain destinations. So for the purpose of this example, let's say that the orcs in Mordor are persona non grata on your website. So there's a easy way that you can filter these out using the MaxMine database. There's a version of it that is available for free and a more robust one that's available commercially. You can hook this into HAProxy as well so that those pesky orcs from Mordor would not be able to access your site if they are originating from an IP in that country. So this is an example of how you would set that up. Again, you load a module, more on that later, along with a database that maps IP address prefixes to their country of origin. And then you tell your front end to reject the content if that IP address is in any of the blocked country lists. Next, let's talk about rate limiting. We mentioned earlier that sometimes users either intentionally or accidentally can try and DDoS your application. So it's useful to put in rate limits to avoid either short-term attacks, trying to bring your server down. It's also a way to limit usage over a period of time, such as limiting the number of API calls. Virtually every public service does this at some rate, and it's very easy to turn this on with HAProxy as well. So we can enable rate limiting by setting up one or more stick tables in this case to track certain information over time. And there's a way to aggregate this across multiple servers in a cluster with a separate bit of software that you can run that will do the aggregation. But if this assumes that you're on a single server, but you can set up rate limits for multiple different conditions. So in this case, we've got 2, which will limit the number of requests that you can make within a 30-second time window. In this case, if you submit more than 300 requests within a 30-second time window, you'll start getting 429 returns, which is that you've exceeded your rate limit. We've also set up so that you'll get rate limited if you exceed 10,000 requests over a 10-minute window. And so you can use some combination of these to protect against short-term, burst attacks, as well as to help prevent someone from, say, downloading your entire database by sequentially, retrieving, records with an auto increment number. Also, don't use auto increment numbers in your URLs, but that's a different story. So HAProxy makes it really easy to add rate limiting at the proxy layer, so this is something your application doesn't even have to be aware of. So you don't have to write in code that does rate limiting. You can just take care of it right at the gateway. Next, let's talk a little bit about logging, because logging is also very, very important. It's all well and good for when your server is doing exactly what it's supposed to do, but when something starts to go sideways, you want to get at it pretty quickly. As we were going through our journey, we decided to use FluentBit because it was very easy to set up and sent structured logs into our SIM tool of choice. So here's an example of how you can configure FluentBit to watch the HAProxy access logs automatically convert those log files with their common HTTP log format into a structured JSON object that gets sent to your SIM tool. So this allows us to parse out all the information. And of course, if you use a custom HAProxy log format, then you can update this regex to match that. But we found that it works really, really well and allows us to have really powerful querying capabilities to filter on activity that we want to keep track of, as well as just generally see if everything's healthy or not. So those are some of the basics that you can set up with HAProxy. If you have access to HAProxy Enterprise, there are a few more that you can look at. HAProxy Enterprise has their advanced WAF that lets you turn on more rule sets in their advanced web application firewall. They go beyond what mod security does, for example, and you can really dial in and tune request patterns to allow your legitimate traffic through, but filter out traffic that is malicious or trying to do something naughty. You can add real-time blacklists for known botnet IPs, for example. You can add more granular geo-IP filtering. Maybe country level isn't good enough. You need to filter by city, state, region, or some other condition. There are options there. And then finally, if you want to go all in, you can go on, deploy some signature-based attack detection, which is out of the scope of this talk. But the point is that HAProxy Enterprise has a lot of extra goodies that you can turn on to make things even more secure. So now let's talk about deployment. Having your config file ready to go is one thing. But now you need to get it out into production in a way that you can be sure that it's correct and also give you a nice way to update it. So I'll just walk you through what we landed on for our own deployment. So everything in production for us is infrastructure as code, as arguably it should be. And so we broke this down into a few different bits of automation that worked in concert to get everything out into production. First, we used Packer, product by HashiCorp, to create our HAProxy base image, where we preloaded FluentBit, the logging configuration that I showed earlier, the mod security and MaxMine plugins, along with the MaxMine database, along with a script that will run via cron every few minutes to check an S3 bucket for updated configuration, updated TLS certificates, etc. We then use Terraform to deploy a highly available active-active configuration in AWS that's fronted by a network load balancer. That's the layer 4 load balancer. And our HAProxy instances are then deployed in a private subnet so that the only attack surface out on the internet itself is whatever the ports are that the NLB exposes, which is just 443 in our case. This is the same active-active configuration that HAProxy has a tutorial for on their docs site when deploying in AWS. Finally, we have Terraform auto-generate our HAProxy config file and save it to the S3 bucket I was mentioning earlier, along with all of our TLS certificates and private keys. Our production instance, we automatically deploy customer instances with custom domain names, and so our configuration updates all the time. And so in order for the configuration to just sort of automatically reload itself, this script will, or Terraform, whenever it does a new deployment, will push all of the new information into an S3 bucket. And then the cron job script will run every few minutes and check to see if there's anything new. It'll pull it down, store it in the right place, and then call system.cutl reload on HAProxy, which will do a hitless reload. HAProxy will reload its configuration without having to restart, which means that we don't have to drop any connections, which is lovely. Finally, I want to talk about some tips and tricks for working in AWS that weren't immediately obvious to us as we were even going through the documentation, and we had some tremendous help from the HAProxy support team, and so I figured I'd share a few of these to hopefully save you some time if you are going through the same thing we did. The first is to enable a DNS resolver to allow HAProxy to use the Route 53 internal zone for resolving its backend calls to your services. So it's pretty straightforward. In your defaults, you add a named resolver, and then in the resolver, the important one there is parse resolve conf. This will parse the resolve conf on the host that HAProxy is running on, which in AWS will be configured to listen to the internal DNS resolver, which can resolve your internal zones, making those available to as target backends. So that can be very, very useful. The next is if you want to use a Elastic load balancer or network load balancer as a backend, there are a couple of things that are non-obvious in order to get this to work. By default, HAProxy will try and store or remember which IP addresses DNS resolves to, which in a sort of classical data center environment is great. But in AWS, since the ELB and NLB IP addresses change rather frequently, the right way to configure this is to tell it to not try and grab an initial IP address. That's that init adder none. So it'll force a lookup of the IP every time, since AWS doesn't guarantee that ELBs and NLBs will have static IPs, or even static IPs for a short period of time. So that's the first one, and that will allow all of your backends to resolve, so that you don't have them a few of them thrashing, saying that it's not available when it actually is available. It's just the IP address of the ELB or the NLB changed. The second one is when you initialize your backend and you use server template, you can set the number of templates to the number of availability zones that ELB or NLB is deployed in. And what will happen behind the scenes is it'll be the equivalent of HAProxy listing out individual servers in that backend for each of the IP addresses that are represented by that load balancer DNS name. So this is very non-obvious, but if you set this, if you deploy your ELB or NLB into multiple availability zones, set the number equal to the same number of zones that is in, and then that way HAProxy will actually talk to all three, and that way you can get high availability for your backend as well. Finally, in summary, security is a good thing and helps you sleep at night, or at least it does for me. And I hope this was helpful to you in hearing our journey as we went through the exercise of setting up a secure proxy for hosting an instance of our product in production. And hopefully some of these tips and tricks will save you the time to go through your logs and figure out why things are not working. Thank you. Finally, one of the reasons why we decided to put this instance of Modzy out is that we are hosting a hackathon. So if that sounds at all interesting to you, you can get information in the QR code on the screen. Thank you very much and have a wonderful day.
And now we have Nathan here joining us live. Nathan, thank you so much for your talk, and thank you for joining us live here. Welcome.
Thank you. It's been a pleasure to be here.
So as a reminder to everyone, you can submit questions for Nathan in the general chat, also on Twitter using hashtag HAProxyConf. So Nathan, we'll get right into some questions. The first one up, was there a moment that made it clear to you that security should be a top priority? Or does this stem from your prior experience?
It's some of both, actually. It's definitely prior experience, but it's also just generally considered best practice, right? You don't want to leave security for the end and then try and bolt something on, because that's when you have lots of holes and different ways to exploit your product. And for our AI product in particular, we're extremely conscious about security, not only for the standard, like cloud-based security and API security, but also our AI model security. So we've invested heavily not only in your sort of standard cloud-based application security best practices, but also we've got some patented work in adversarial defense, and we work quite a bit on explainability and drift detection, all these things that are important for securing AI models as well. So if you don't think about security at the very, very, very beginning and plan that into how you build your architecture, then you're going to have a hard time actually achieving the amount of security that you want by the time you get to the end.
Yep. So for you, security is really foundational.
Absolutely paramount.
Great. So when did you actually realize that HAProxy could be used as a layer of security, or did you always see HAProxy as more than just a proxy or load balancer?
I've always seen it as more than just a proxy or load balancer. Great security is security in depth, and your load balancer on the outside or your reverse proxy was usually one of the first parts of your stack that traffic comes in on. And the more traffic that you can filter out at that layer, the less you then have to handle on the inside. And so, not only has HAProxy, been a leading, load balancer and reverse proxy, But it's also the perfect opportunity to do things like I mentioned in my talk, like geo-IP filtering and things of that nature, because you'll know immediately as soon as those packets coming in whether or not you don't even want them. And so, it saves on, load on your application servers. It means that, malicious traffic doesn't even get past the door. And so it's a very prime place and opportunity to have your sort of first layer of defense.
Sure. And speaking of these layers of security, I know it is something that people think about balancing security with performance. So in your experience, how is adding these different layers of security affecting things like throughput?
Yeah, so security is one of those things you don't really want to compromise on, but performance is something you also don't really want to compromise on. And so one of the advantages of thinking about security at the very, very beginning of your architecture designs is you can figure out where do these security checks take place, which ones are on the critical path for achieving that performance that you want, and then you can build in caching if necessary, but make sure that you're sort of reducing the amount of external lookups to authorization servers or external databases or things like that, to make sure that you keep those latencies down without compromising on the security that you want to achieve. And so that's one reason why it's really important to start very early in your designs rather than trying to bolt it on at the end, because then security becomes like ingrained as an integral part of your architecture, rather than something that you just added on later.
Yep. We do have another question that just came in from the chat, which is, are you sending HAProxy logs to both an SIEM and FluentD, or is FluentD used as an SIEM?
So FluentD is used as the transport to forward our logs to our SIM tool. So all it is it's a log aggregator, and so it'll read the logs, or tail the logs from the pods or the hosts, and then forward those to your SIM of choice. Whether it be Elasticsearch or Splunk or CloudWatch or or whatever. So FluentD is just the thing that sort of packages up all the logs, converts them into a structured data format, in this case JSON, and then sends those off to your log analysis management and security tool of choice.
Great. And as we wrap up here, Nathan, do you have any parting thoughts, any tips that you'd like to share with the audience?
I just wanted to mention briefly, as I did on my last slide, that Modsy is currently in the middle of a hackathon, where we have $25,000 of prize money up for grabs. If you want more information about that, there was a QR code on the last slide, which you can go back and find, or you can go to modsy.com to find a link. But we hope to see you there, hope to see your great ideas, and see what kind of cool things you can come up with if you have AI at your fingertips with just an API call.
Yeah, in 25K, that's nothing to snub your nose at. So definitely interested in checking that out. And if anyone wants to catch the Nathan's presentation or any of the presentations today, they're going to be live on the website and then published in the coming weeks as well. And again, you can visit that QR code that he mentioned. Great, Nathan. Thank you so much for joining us. Thank you for participating in HAProxyConf 2021 and for joining us for the live Q&A. Enjoy the rest of your day.
It's been my pleasure. Thank you.